In this video, we are going to learn how to interpret the graph of a function to get the information about its first and second derivative. Here are the four different cases of the graph. First one, when the graph is coming downward, that means function is decreasing. For a decreasing function, first derivative is always negative. This one is increasing. For an increasing function, first derivative is always positive. This one is again increasing, so the first derivative is going to be positive. For this decreasing curve, first derivative is negative. Next is concavity. Concavity always deals with the second derivative. When the part of curve is concave up, second derivative is positive, and when the part of curve is concave down, second derivative is negative. So for an increasing function, first derivative is always positive. For a decreasing one, first derivative is always negative. When the function is concave up, the second derivative is positive, and when the function is concave down, second derivative is negative. Now let us see how these concepts are used in solving this problem. We need to check the values of f of 2, f prime 2 and f double prime 2 and write them in correct order. So this is the graph of the function f. This graph tells us the y values of the function. So we need to look at the y value when x is 2. When x is 2, y is 0. Since this point is 2, 0, that means here we have f2 equals 0. Then we check whether the function is increasing or decreasing. From here to here, this graph is decreasing, and we know that for a decreasing curve, first derivative is always negative. F prime 2 is going to be negative. And then we check the concavity. We see that at this point it's concave up, and we know that when the graph is concave up, the second derivative is positive. That means the second derivative at 2 is positive because the graph is concave up here. Now we write these values in correct order. First we write the negative value, then 0 and then positive. So the correct option out of the given option is second one. This one is the right option. Now let's work on a similar problem. Here we need to check the function value and the value of derivatives at negative 2. This is the graph of the function fx given here, and we see that at negative 2 the value of this function is 0. So this point is negative 2, 0, and we can write this as f of negative 2 equals 0. We see that the graph is decreasing here. That means the first derivative at this point is going to be negative, and the graph is concave up on this interval. So the second derivative is going to be positive. And now we can write them in correct order. First we write the negative value. Because the first derivative is negative, then f of negative 2 is 0. And then f double prime negative 2 is positive. So this is the correct option. For this next problem, we are given the derivative graph f prime x, and using the same concept, we need to extract the information about the function graph, about the graph of f of x. First we check whether the derivative is positive or negative. Since the derivative graph is above x-axis from negative 3 to 0 and 0 to 3, that means the derivative is positive, which means the function is increasing from negative 3 to 0 and again from 0 to 3. So the function is always increasing on this domain. Next we check the concavity. For that we look at the slope of this derivative graph. We see that from negative 3 to 0 the derivative graph is decreasing. That means slope of this graph is negative, which means second derivative is going to be negative on this interval. We can write this information as function is concave down on this interval. For this next part from 0 to 3, this derivative graph is increasing. That means the slope of this derivative is positive, which means the second derivative is positive on this interval. The function is going to be concave up on this interval. And now using all this information, we can check the correct option. We see the first one, it's increasing. from -3 to 0 and then 0 to 3. For the first part it's concave down, for the next part it's concave up. So this graph, the first graph, is going to be the correct option for the given derivative graph. We see that on the third option the graph is concave down and up on the same intervals, but this graph is disconnected. When the derivative is a continuous graph, then the original function must be a continuous graph, because only a continuous function is differentiable. So the third option is not the right one, only the first one is the correct option.